Hi, my name is Nicholas Kennedy, and today I'll be installing Sterling Secure Proxy on an OpenShift 4.14 cluster. As you can see, I've already got a cluster, and I have created a project or namespace, if you're familiar with Kubernetes, that I'm calling SSP for Sterling Secure Proxy. I'll be using container version 6.1.0, and I'm assuming that the person watching this has a basic understanding of Kubernetes and OpenShift topics and general considerations. I also already have Argo CD installed on this cluster. I did not do any special configuration because this is a demo cluster. I simply followed the OpenShift installation documentation for it. Not very difficult to get available. And now we are ready to go through the prerequisites. You'll need to, of course, get a namespace or a project, which is as simple as running your OC new project command with the name after. Once you've set up your project, we'll go ahead and download our Helm charts. We actually have 2 Helm charts that we're using for this, and I am already authenticated to IBM's entitled registry. But in order for you to pull these images, you will also need to be logged in to cp.icr.io, which is IBM's container registry. Which this is very simple. I'm not going to redo the command here because I'm already authenticated, but you'll need to do a docker login cp.icr.io. You'll see a prompt for username. We can enter CP, and for the password, we would enter our IBM entitlement key. I've already entered my entitlement key, so I don't need to do this again, but you'll need to. Once you've done this, we can go ahead and pull our Helm charts down. So I'm assuming that you have Helm installed. You can check by simply running Helm. It'll show you a list of all of the commands. I've already added the repo, which you can simply copy paste this command. Once you've added the repo, you can verify by just running Helm repo list. We can see I have the IBM Helm already included. After this, we can go ahead and pull our 2 Helm charts. I'm not using the perimeter server in this demo. It is the same configuration, so if you'd like to include it, there is just a 3rd component to include. So once you've pulled these, you're going to see 2 zip files in the form of IBM SSP CM and engine that you can unzip to see Helm charts. So there are a couple ways that you can work with these Helm charts. If you're familiar with Kubernetes, you'll see your classic templates. You'll see the PV claims, role bindings, routes. Most of this is configured automatically for you through the Helm charts that Sterling Secure Proxy has. You can do a lot of this information directly through the values.yaml for both the configuration manager and for the engine. This is a pretty comprehensive values file, so it's easy to get lost. So I will actually just be highlighting a couple of important areas. Obviously, make sure that you have your license set to either prod or non-prod. Despite what this says, it is not non-production that you need. If you're using non-prod, it's actually just non-prod. For the license, you'll have to accept it as true for both prod and non-prod, otherwise it won't install. Your architecture, currently they only officially support AMD 64, and in an alternative video, I can show you ways that using Docker X you can configure images for ARM or Power, PPC64LE, whatever you'd like to do. The time zone is not important in this context. You will need to ensure that the repository that you're pulling from either points to that private repository or points to the IBM public-facing cp.icr.io. You can see this Docker image that we'll be getting, our image version. There are no image secrets, and we are going to use a digest to get the exact version of the product that we want. For the CM args, most of these you can keep the same for a demo environment. You will obviously need to configure these to match a production environment. For persistent volume, in a later step, I'm going to show you that we actually configure this by adding our own PVC via a Helm umbrella chart. So in Helm charts, an umbrella chart is essentially a wrapper around your base chart, which is what this is, that gives you additional configuration. So for example, this assumes that you already have a PVC, so you're probably used to doing things to set up an application like OC apply -f, our PVC, our PV, our service accounts, etc., etc. With the umbrella chart, we can actually automate a lot of this away. And depending on how you configure your production environment, we can also use this to scale the application itself. So for the rest of this video, I'm going to move away from the base Helm chart and into my personally configured Helm chart. So I have a repository that I have set up for IBM Sterling Secure Proxy. And as you can see, in my IBM Sterling Secure Proxy Configuration Manager folder, IBM SSP CM, I have created an umbrella chart that is simply a wrapper around our base configuration manager. So using this, you can see the chart version that I've set up is identical, except that instead of using the IBM SSP base Helm as the actual name, we are using it as a dependency here. And then for my values.yaml, I've created a subsection to match this name. And this is important that this dependency here matches here. Otherwise, it won't pick up on the right dependency for changing these values. So you can see that I've added the namespace that I'll be deploying to. That's an additional prereq based on some of the additional files I've created. And then down further, you can see that I've simply said, okay, we're going to take an existing claim, SSP-CM-PVC. We're going to make it 2 GB. And based on the storage class name of my cluster, I am looking for an NFS or file system style storage class. Mine is an ODF enabled cluster, which is perfect. I'm going to go to my storage classes. I'm going to look for one that is the file system. So once we have configured our storage class name and set it to read write once, we are going to go through the rest. Most of this I've kept the same. Once again, our storage security, FS group and supplemental groups are just how you gain access to the NFS, especially if root squash is enabled. There are ways around these security. I'm not going to get into them because it's outside of the scope of this video. However, it is important information to have anytime you're mounting file systems to a Linux node. So as you can see in my service, I have selected type node port, meaning that for the external connections to my cluster, I would like to have a port exposed on my nodes, my physical VMs, that I can access. And continuing down, we've configured a secret, which will be in our templates, that has all of the passcodes that SSP requires. They are base 64 encoded. And then we've selected to create our service account dynamically. We allow the application to create its own service account. If you don't like that, it's very easy to create a service account and give it the permissions required. Here I've doubled the CPU and memory available to the configuration manager simply because it runs a little faster and it's a demo environment. I have plenty of space. liveness probe, ready probe, you can change these values to match, your environment standards. Route enabled, I set this to true to automatically expose the service in OpenShift. If you'd rather not, you can simply use that node port value that we specified further up. VM arguments, custom certificates, these are all production values. Of course, if you're working with Sterling Secure Proxy, you're probably going to care about your certificates. You'll need to update all of these to match the secret and the alias of all of your certificates in a production environment. So continuing on, past the certificates, past our SSL, we can see our network policy. Once again, you will need to apply your ingress and egress to match the environment of your OpenShift cluster. These values could change based on which ports you need exposed, whether or not you're using a load balancer. Okay, so first thing that we want to do after we have this set up is I would like to get my OpenShift security context constraint configured. This is an OpenShift custom resource definition that allows us to specify Linux permissions and Linux capabilities for the pod itself. The SCCs, I believe that OpenShift comes with 11 SCCs by default. We should be able to check them here. Security, context constraints, instances. Looks like there's a few more because we're running rook ceph under the hood, but the typical ones are any UID, host access, host mount any UID, etc., etc., etc. All of these are available on OpenShift's website if you'd like to see the specific permissions. You can also click into them and check the YAML itself. If you go down here, you could see what it gives access to and what type of resources or API groups it manages. So the first step would be doing our OC apply -f on our OpenShift-sec.yaml, and then it'll confirm that it's done this. After that, you would apply the cluster role, which essentially this will, of course, add a cluster role that's available to all of the security context constraints. This allows us to bind our security context constraints to roles in our cluster. So once we've done this, we are good. If you're not using the umbrella Helm chart to do a typical Helm install, which is a completely different topic, because here we'll be using Argo CD. There are two ways to perform GitOps against something like this. The first is to go to your Argo CD instance, click New Application, name your application, whatever you need to name it. Here I'm selecting project name as default. Don't let this trip you up. This is the default project name inside of Argo CD. So this project name is relative to Argo CD. This is handy for larger projects when you're separating resources and so your teams don't get confused. This is not an OpenShift project. This is not a Kubernetes namespace. This is an Argo CD project. Cannot emphasize this enough. You see that we have plenty of sync options available to us. You can see we can add a deletion finalizer, an important aspect of Kubernetes. We have auto create namespace, apply out of sync only, etc., etc. I'll allow you to dig through these at your own will. But the important step is going to be grabbing our Git repo. So it's going to need your .git, and you'll paste this, your repository URL. For path, I actually have two Helm charts in a single repo. I am currently deploying the configuration manager. I'm going to select the configuration manager path so that I point to a specific Helm chart. For cluster URL, Since I am using this Argo CD instance inside of the same cluster that I'm deploying resources to, I'm going to use the Kubernetes default service, which is essentially the default endpoint to internal services on the same cluster. For namespace, I will select SSP because that's the namespace I've created for myself here. And then for Helm, for the values file, I'll select values.yaml because that's what I've named my values here. Now, I'm not actually going to create this resource here because I've added some additional configuration, which I can go over. It's really common that service accounts change post-sync. They still sync successfully. However, they will show as out of sync. So in order to make sure that, it just looks nice on my Argo CD dashboard, I've added this section about ignoring differences under service accounts. So all I'm going to do is go to my command line and do an OC apply -f on my SSPCM application. This will automatically deploy an application object to Argo CD, as you can see. And then I'll do the same thing for my engine. This will deploy a second application. In this example, for the purposes of the video, I've selected a manual sync. So as you can see, both of my objects are out of sync. So let's go ahead and see if we've configured this correctly. I'm going to sync. This shows all of the resources that I'm currently syncing to my cluster. I'll sync the configuration manager, and thanks to the additional configuration that I've set up, I also can sync my engine without waiting for the configuration manager to finish syncing up. And this becomes important because for Sterling Secure Proxy to communicate internally, there is a key cert handoff that happens from either the engine or the configuration manager, which we configure in our values.yaml. Key cert export on line 46 with our key cert alias name as key cert. So you can see that for my CM, I've selected the key cert export to be true. And for my engine, this should be false, which it is. And this is important because in order for them to communicate, they need to share that key cert. So let's go back to OpenShift and look at our resources. We can see that our configuration manager pod is spinning up. You can go into the logs and see that our installation is completed. It's probably still booting behind the scene, which is why this ready state is not showing as 1 of 1 yet. And you can always view what the hanging ready states are by simply going to the readiness probe inside of the cluster, or inside of the pod, excuse me, and seeing what exactly they're running. So for example, here they're just running bash-c on a monitor service.sh and checking if port 8443 presumably returns something. So this is just waiting for that service to come up. So we can go to networking, services. We can see that our services are available with our 2 node ports exposed. And now we simply wait for these to spin up. If you'd like a nicer GUI, you can actually click into the application in Argo CD, and you can view all of these resources as they spin up, and you can see which resources are out of sync, which resources are currently syncing, and what is still being spun up. Okay. Our configuration manager pod is ready, 1 of 1. Here you can see I'm performing a key cert handoff job. This is actually a custom job that I've created to make this a smoother process. Their official documentation is a little more constrained in how they handle this. They recommend that you actually SCP it into the second pod. Instead, what I've done, because I always know that I want 1-in-1 for demo purposes in this context, is I have created a template for a role, which has the ability to get and watch and create pods and secrets, a role binding, for the service account that I'm creating, and then the job itself. This key cert handoff does exactly what you'd expect. It's a Linux Alpine image with K8s installed already, essentially allowing me to perform Kubernetes commands against this pod. You can see that I'm entering the shell, and then I'm waiting for the condition of the pod, which is a parameter I'm passing in, to be ready. And I wait 1200 seconds. And if you are curious about that pod value, that is going to be right here, env. So here, because of the way that these pods are spun up, it's a combination of the release name and IBM SSPCM-0. This was the easiest way for me to do this on a short notice. Once that is done waiting, it actually just creates a secret from the file on that pod, because I am mounting that PVC to this pod as well. It's probably not the most secure way to do this, but once again, this is for demo purposes only. And once the job is done, it spins itself down anyway, so there's not much time to access that information. And moving back to our engine, you can see that our engine is no longer in a init because it received that key cert, and now it's ready to start our installation. And once the engine is done and in ready state, you have Sterling Secure Proxy installed and configured on your cluster. From there, you can do your standard availability checks. And that should be everything that we need for this installation. If there's anything that you see that I have missed or that you would have liked to see in this video instead, please feel free to reach out to me. My name again is Nicholas Kennedy. I'm very easy to find. My name is unique. And have a good day.